Okay, YouTube, this is my first video on writing the equation of lines or writing linear equations. And what I like to do is point out first in this video what the concept of slope is and also some core concepts in terms of how you write the equation of a line. But you'll notice that I've got a couple of tables here and I want to start with the slope formula. Okay, so when we discuss the slope of a line, we're talking about something that has a constant rate of change. So this is a line, as a matter of fact. We could say it is never changing how it increases. So to describe the slope of this line, really all we're really doing is measuring what we refer to as a rise to run ratio. Okay, you'll notice that this line here, it looks the way I've drawn it, it runs a little bit more than it rises. But again, we say that the slope of a line is defined as being its rise over its run. So you'll notice that I have m is the letter that we use here for slope. And we define it as being rise over run, where our rise is the change in y over change in x. Okay. So you'll notice that I say the slope of a line passing through 2 points, x1 and y1, and x2 and y2 is equal to the difference in the y values over the difference in the x values. The reason why we get this is because let's say we do have 2 points on this line, and it really doesn't matter what 2 points we have. If I know this is x1, I know this is y1, and this is x2 and y2 respectively, then we'd say that the change in the y values here would represent its rise. That is, we could say take y2, this height here y2, and this height here y1, and put them in a difference with one another. We'd say y2 minus y1 would represent that change, or this distance right here, whereas if we were to deviate down here, we say this is x1, and dropping this down, we have x2 here. Basically, to find this distance, we'd say take x2 minus x1, and that's how we're getting this slope formula. We say the rise over run is change in y over change in x. So a few quick notes. We say if m is positive, the line rises from left to right. Okay, we would have had a positive number, positive rise over a positive run. So positive over a positive is a positive. But if m is negative, we say the line falls from left to right. In a hypothetical instance here, if we had a line that would have proceeded thusly, we would have said it would have a negative rise but a positive run. Negative over a positive is negative, okay? Notably, we say if m is equal to 0, then the line is horizontal. Okay, so we have a negative slope, a positive slope. If we had a 0 slope, that would be some line that always runs but never rises. So between any two given points on here, we say the rise is 0, but the run is this distance. And so if m is some 0 over some distance, we'll call it a constant c here. Or maybe that's the distance there. We would say that the slope comes out to be 0. And then last but not least, we'd say it will be a vertical line if it is undefined slope, or it will be undefined slope if it's a vertical line, because our rise to run ratio would mean that we're always rising some constant but never running, and division by 0 results in undefined values. So when we look at the slope of a line here, we use the letter m. What I'd like to do is for all four of these, basically just go find the slope of the line passing through these 2 points using the slope formula that we've defined thusly, okay? And also state whether the line is rising, falling, horizontal, or vertical. So let's look at this first example here. We say through 1, 3, and negative 2, 7. Now, I am a big believer in visually representing this. And if we were to actually sketch this out, we'd say, well, one of our points is right 1, up 3. So that's this point here. We have 1, 3. And we have left 2, down 7. So 1, 2, 3, 4, 5, 6, 7. So that would be here. We'd say this is negative 2, comma 7. Negative 7. Ooh, I just noticed something here is positive 7, isn't it? 5, 6, 7. Whoops. That's better. We say that this is negative 2, positive 7. So we have a line passing through these 2 points. And the reason why I'm a big believer in visually sketching this is because I can already tell you that this is going to fall and it has a negative slope. Okay, it is falling. But in order to find the slope here, we'd say that this is really our x1 and our y1. We have an x2 and a y2. And so if we're just going to put this in the formula, we'd say, well, then our formula would dictate that we have a difference quotient here. So we would say in the first spot here, we have y2 is 7 and y1 is 3. We have x2 is this negative 2 right here, and our x1 is 1. So finding this quotient here, we can see that this is 4 over negative 3. So in other words, the slope is negative 4/3, and we can actually verify this visually by saying it goes down 4 right 3. We notice visually that it goes down 4 right 3. So rise over run, negative 4/3. Let's take a look at letter B here. Now, just using the slope formula without visualizing this, we could do the same thing. We could say it is a difference quotient. And we say that our y2 in this case is negative 2. Our y1 is negative 2. It's important that we actually put that in there with the difference between them. And we say, okay, well now I've got 4 minus 1. So this double negative here becomes a double positive. And we say -2 plus a +2. What this is going to result in is 0 as a rise. And we say the run is 3. Regardless, though, we'd say because the slope is 0, this must be a horizontal line. Horizontal. Okay. So we say, how about through the points -1, 3 and -1, 1? So again, using our slope formula here, say it's our difference quotient. We say y2 is -1, y1 is 3. x2 now is -1, and x1 is -1. So you notice that the 0 that we end up with actually results in the bottom of this quotient here this time. And we end up with -4 over 0. So what we're going to say is this is undefined. And you know what? I would like to visualize this here. If we went and graphed these, we say -1, 3 and -1, 1. We'll just click over to Desmos here. It's really easy to put in. So we have -1, 3, and -1, comma 3, and -1, comma 1. We can see that these 2 points here are located directly above one another. So the rise over run ratio here is it rises 2 but runs none. And if it rises 2 and runs none, then we're going to have an undefined slope here. Okay. So let's consider this. Oops. This is a -1 here. Okay, so rises 4 and runs none. And as a matter of fact, that's what we calculated over here. So last but not least, we say, okay, 0, 1, and 3, 7. Let's calculate its slope. And we'd say that this is 7 minus 1 on top, 3 minus 0 on bottom. So we get 6/3, and we could actually simplify this to say that it's 2. So it rises 6 for every time it runs 3, this line here. So this must be a rising line from left to right. But that's the basics of slope. When we get into the next video, we'll interpret that a little bit more in detail.